Right, what we're studying in chapter 7 and combining it with 8 is a lot of similarity ideas where the shapes are not going to be always the identical size. One's going to be larger, smaller. If you think about the tangram pieces that you just had, there are 3 sizes of right triangles. A little right triangle, a little bit bigger, and then the 6 and 7 were larger yet. They are all similar triangles, but they were not congruent triangles. So we're going to be focusing more on similarity. So there are going to be a lot of ratios and proportions. That's mostly what today's lesson deals with, is working with remembering, refreshing your memory about ratios and proportions, and then talking about what's called a geometric mean. That's the part of chapter 8 we're going to pull in today. If you're a fan of something like Lord of the Rings, you are familiar with, or at least if you really think about it, they used a lot of ratios and proportions in there because when they made the things that they filmed on, doesn't show up real good, do I do that? They made a detailed miniature model in order to do the filming of some of that. And so in order for it to look realistic, they had to be careful of what scale factor they used. They didn't want something to be distorted in relation to the things around it. So using a scale factor in models of all kinds, there really are a lot of uses of scale factors in real life situations. Any of you fans of Lord of the Rings?
Yeah, I am.
All right. So, and that would be just one example. There would be a lot of other things. Okay. So what's a ratio? Ratio is a comparison of 2 numbers using division. Comparison of 2 numbers by division. So that means that when we do the idea of the scale factor, we're going to either divide by something, or if we're dividing by a fraction, to make it like half as big or something, I guess that would be dividing by a fraction. But it could end up that it's really multiplying to make it larger. So multiplying and dividing, not just by adding or subtracting. Okay, ratios can be written in different ways. Probably with the word 2 is the least common used, at least in our math books. But you can write A to B for a ratio. You can put A colon B for a ratio, or you can write it just like a fraction, A over B. And the B can never be 0 because that would be like dividing by 0 or comparing to 0, and that's not going to give you a ratio. So as we go through this chapter, realize when we got something in fraction form that maybe reduces to just 3, and we want a ratio, 3 is not a ratio. You would have to leave it written as 3 to 1. So the context that we're working in is what we need to be thinking of. Is it a ratio, and if so, I need the 2 numbers. Okay, and I mentioned the denominator can't be 0 because dividing by 0 is undefined. Slope is a ratio that you've used a lot in Algebra 1. So this should be an easy ratio. Believe it or not, this is the kind of question that most students miss on my test on this chapter. I don't know why, but all I'm asking you to do is write a ratio expressing the slope of the line. What's the slope of that line? Calculate it for me. What's the slope of that line? What to what? That's a ratio. Miss it, or are you gonna get it right? Suspense is building, right? Slope is -5 over 3. So how many got it right? And it's going down. So slope is really just a ratio, comparison of 2 numbers. The 2 things we're comparing are the rise and the run. So that's just simply an example of a ratio. Without the picture, can you do it right? Let's see if we can get 100% this time. Given those 2 points that are on line L, write the ratio expressing the slope of line L. Find the slope, make sure you give me a ratio. What to what? Answer is, some of you are using marker boards. 1/4? Now we gotta write that time. All right, gotta get good at just figuring out slope. Okay, ratios can involve more than 2 numbers. If so, they're usually called an extended ratio. And in our geometry concepts, we can write things with an extended ratio. For instance, if we're doing the ratio of the side lengths of a rectangle, there's 4 sides. So the ratio could be written 3:7, 3:3:7. So there's 4 numbers in this comparison instead of just 2. So that doesn't exactly fit the definition of one ratio. It's really multiple ratios kind of put together. But we can use that in order to solve a story type problem. It says, for this rectangle, I want the ratio of sides to be 3:7 to 3:7. If the perimeter of the rectangle is 80 inches, how long is each side? Now, can each side be 3, 7, 3, 7? What's that add up to be? 20? But we want the perimeter to be 80. So you can't just stick with the 3 and the 7s. You have to multiply it by something to get it bigger. How much do we have to multiply it by? Okay, so we may realize 4. So how do we come up with that? Because it's not always going to be a whole number all the time. So instead of just 3 and 7s, we're going to use 3 times something, 7 times something to represent the sides. Why don't you write this example down? Off to the side or something. Right off the space, something like that. So the side lengths are in the ratio 3:7 to 3:7. We're going to multiply each of those times something like x. And then we want to add them all together. In other words, we want the perimeter, when you add all those sides, we want it to equal 80. So just think about how we're using the ratio. All right, solve for x. What are the actual side lengths? 3 times, you find x to be 4. So 3 times 4 is 12. 7 times 4 is 28. So let's see, does that really give us a perimeter of 80? We add 12 and 28 and another 12 and another 28. Adds up to 80 total. And is that in the ratio that we want? 12 to 28 to 12 to 28. What can you divide all of those by? Not by 3. Can't divide that by 3. 4. Divide by 4 makes 3 to 7 to 3 to 7. That's the ratio we wanted it to have. We just had to make it big enough to get the correct perimeter. All right, so that's an example of perimeter with a rectangle. Next one's an example of area or of angles, I think, in a triangle. Okay, done with that one? All right, so now work on this one, thinking how can I apply what we just talked about in a new situation? The ratio of the side lengths of a triangle is 4:7:5, and its perimeter is 96. What's the length of the shortest side? I guess I still stuck with perimeter. I must have another example. So how can you apply this to a different shape? That's the shortest side. Brendan, you still with us? Not feeling well or just real tired? Should be 24. Okay, the side lengths all add up to 96, and then the shortest one would be the 24. How about angle measures? This is the one I was thinking came next. What's the ratio the angle measures in a triangle is 1 to 6 to 13. What's the measure of each angle? Angles in a triangle. Like most of you figured out that you have to set it equal to 180 because we're talking about the degrees in the triangle. Looking at your boards, I think most of you are doing it the right way. Got 1x plus 6x plus 13x equals 180. When you solve, x was 9, and each angle then would be 9 degrees, 54 degrees, and 117 degrees. All right, got the idea how you can use the ratio with the variable in order to multiply. Questions before I move on? Okay. Proportion. So here's a definition. Once we have one ratio, then if we have two ratios that are equal, that makes a proportion. A proportion is an equation stating that two ratios are equal. In the proportion A over B equals C over D, the values of A and D are called the extremes. The B and the C are called the means. Means and extremes, those words will be used in a theorem or property that we have here in just a little bit. Now, if you want a way to remember which are the means and which are the extremes, if you would write that same proportion with the colon, A to B equals C to D, and then kind of apply what does the word extreme mean? And what does the word mean mean? Okay, in Nebraska, we have extreme temperatures, really cold, really hot. So the numbers on the outside, and in this case, the variables, the A and the D on the outside of that proportion, written this way, the A and the D, those are the extremes. Makes more sense in this form. Like that. And then the middle ones, that would be like mean, average, middle kind of ideas. Those are the means. The bottom one there, the top one there, those are the means. And these red ones are the extremes. As I draw those circles in there, does that remind you of how you might solve that? You did these in algebra. How did you solve something like 6 over 5 equals x over 21? It's cross multiplying, cross product. I didn't hear anybody say fish method, but I know I've heard that over the years. Were any of you in the middle school when they were using fish method as far as terminology? That's what this is as far as solving. The fish method only works for the simple problems. It really doesn't work well for the bigger ones. But cross product property is how we go about solving proportions. Popped out of it again here. Didn't it do this the other day? Yeah. Okay. My touch must be off a little bit. Let me try one more time. Okay. All right. Clear the ink over here. I must have to align it a little bit. Come on. I'll erase it. Why it's not disappearing. Okay, solve the proportion. 7 over x equals 56 over 72. Cross product. Did I go past the notes? Yes, I did. Okay. So do you understand what you're doing? Cross multiplying? Okay. I think most of that was written in your notes. Just to make sure that I didn't skip over that. Okay, so back to the problem you're doing. 7 over x equals 56 over 72. While you're working, you got it written down. I'm going to outline my board. Multiplying 7 times 72 and 56 times x. Multiply and then divide by 56. X should have been 9. Question coming up with that one. Okay, that's your simplest one. Let's do 100 over x equals x over 4. Solve the proportion. Cross product property. What's x times x? X squared. It's not 2x. That's when you add. X times x is x squared. So you're going to have to do a square root to solve. Remember when you square root, there would be a positive number and a negative value that would square to give you 100. Or 400, I guess. I can't say 100. What times what is 400? What times itself is 400? 20 times 20? Okay, so your two answers should be positive 20 and also negative 20. Remember how you could write that together, positive and negative, the plus minus out front? Means those two answers, two solutions. Got that one mastered? Question on why I have the two answers? We didn't have that on the last one because you didn't square root at all. Okay, a tougher proportion. Solve the proportion. X over 2 equals 10 over x plus 1. Hard to be mentally. Okay, multiply x times x plus 1. 2 times 10. This has a different look to it, right? Because when you multiply, don't you get x squared plus x equals 2 times 10, which is 20. So I get x squared plus x equals 20. Okay, what I'm doing is just multiplying. X times x is x squared. X times 1 is 1x. If you want to write the 1 there, that's fine. Okay, now you cannot just do what you did on the others. You can't just divide by something. You can't combine the x squared and the x. Remember good old quadratic formula? This is what you have to use the quadratic formula on. Okay, now before you pick out the a, b, c, so yeah, you probably want to write the formula down again. Second one down under the Pythagorean theorem, that's our quadratic formula, which is used to solve problems like this. We have to pick out what the a, the b, and the c are, but to do that, you have to get the equation equal to 0. So where we're at in this problem, subtract 20 from each side, so that you have x squared plus x minus 20 equals 0. It has to be equal to 0 before you can pick out your a, b, and c. Okay, so what's the a value going to be? It's the coefficient on the squared term. So a is going to be 1. B is the coefficient on the linear term, the part that doesn't have an exponent. So b is going to be 1. And c is the constant, negative 20. I forgot c. C equals negative 20. Okay, so let's plug through that quadratic formula. Come up with what our two x values are. When do you have to use that quadratic formula? When you've got the squared term and the linear term. So you've got an x squared and an x, because you can't combine those in any way. Sometimes you can do some factoring and solving, but quadratic formula probably will work for us. So x equals the opposite of the b, plus and minus, the square root of b value squared minus 4 times the a times the c, and then all of that is divided by 2 times whatever the a is. If I remember on the worksheet where we had some of those, a few people didn't divide the whole thing by the 2a. You're only dividing part of it. Okay, so a lot of what we have to simplify is what's in the parentheses there. Okay, so we got negative 1 plus and minus square root of 1 minus negative 80, which is going to be plus positive 80. So that's an 81. Negative 1 plus and minus the square root of 81 divided by 2. Square root of 81, recognize that? 9. So x is negative 1 plus and minus 9 divided by 2. So there's going to be two answers on this. One is what you get when you add. The other is what you get when you subtract. So x is going to be negative 1 plus 9. That's 8 divided by 2, 4. And then negative 1 minus 9, which is negative 10, divided by 2, negative 5. So to solve that proportion, x could be 4, x could be negative 5. I want to convince you that those are really the answers. So just to convince you, I'd go back here and plug them in. If I put a 4 here and a 4 here, 4 over 2 is 2 to 1. 10 over a total of 5 is also 2 to 1. What if I put in negative 5? This doesn't reduce, negative 5 over 2. 10 over negative 4, that does reduce. Negative 5 over 2, just like this side is negative 5 over 2. So both numbers do work. So occasionally, you'll need that quadratic formula. Questions before I go on? Okay. Come on, cooperate. Okay, this was the one we just did. All right, let's do z minus 4 over 5 equals 20 over z minus 4. A bit of algebra practice here today. Multiply your z minus 4 times your z minus 4. Before you pick out your A, B, and C, you've got to have it equal to 0. Do your foiling, multiply the z plus minus 4's together. So you only have half of it. You just did the product of the extremes. You need to have equals 5 times 20. You don't need to have that one. Okay, so when you multiplied this out, z minus 4 times another z minus 4, that should be z squared minus 4z minus another 4z plus 16. Some of you were forgetting the other half of the equation, equals 0, or equals 100. Z squared minus 8z plus 16 equals 100. Subtract 100. Z squared minus 8z minus 84. Equals 0. So A is 1, B is negative 8, C is negative 84. Plug through the quadratic formula then. Have two answers in the end. If you double stack them, it would be 14, it would be 10 over 5, 20 over 10, 2 to 1 on both of those. be a positive 8 because it's the opposite of negative 8. Opposite of negative 8. That should be a negative on the 6.
Oh, yeah,
Negative 12 is that much.
that makes more sense.
It wasn't checking maybe.
No,
Maybe
that's
that's
like 4.
It shouldn't be a negative 400. This should be a positive. When you take negative 8, technically you should have parentheses around that. Negative 8 times negative 8 is positive 64. You want me to show the complete quadratic formula going through it? Some are saying yes, so I don't know that I have that completely written out. So we should have positive 8 plus and minus square root of 64 plus, what was 4 times 84? 336. And so when you added, that was 400. Square root of 400 is 20. So it should have been 8 plus 20 divided by 2 and 8 minus 20 divided by 2. So 28 divided by 2, one answer was 14. 8 minus 20 was negative 12 divided by 2, negative 6. Well, these are the hardest ones to solve because it takes you a little while to get through the quadratic formula. Okay, questions to clarify? No? Okay. There's a special proportion that uses what's called the geometric mean. So I'm going to skip through a few examples here. There is a different method to solve those, but I'm going to skip that. So let's talk about the geometric mean. And that's actually in the lesson 8.1. So if you'll flip in your notes, once I get there completely, to 8.1. As we have time, we can go back and solve a few more of these quadratics. Trying to get to what I wanted. All right, here's where I'm on. 8.1, a geometric mean. Probably about halfway through your packet. And there's more days that we'll talk about things in this section, but I want to just have you write down what a geometric mean is, so that definition kind of in the middle of your paper. A geometric mean will always be of two positive numbers. It's the positive square root of their product. The geometric mean of two numbers is the positive square root of their product. So where does that come from? If you look at the beginning part of this screen, the proportion a over x and x over b is a setup to find a geometric mean. Why that setup? It actually has to do with similar triangles, and we'll look at those similar triangles from lesson 8.1 in another day or two. But the geometric mean, remember which are the means and the extremes? The two x's are in the means locations. A geometric mean is the same value for each mean position in that proportion. So the A and the B are the two numbers that you're gonna be interested in. So if I'm asking you, what is the geometric mean of 4 and 25? What's the geometric mean of 4 and 25? That would mean I'm looking for the geometric mean, the same number both places in the mean proportion. 4 and 25 would be the two numbers in that proportion that I'm trying to find the geometric mean of. If I were to solve that, just like what we were working on, wouldn't you cross multiply? X times x is x squared. 4 times 25 is 100. And then you need quadratic formula for this one? No, you can just square root. Okay, square root of 100 would be 10, but also negative 10. So when you're solving, it's positive and negative. A geometric mean is not a negative. So in this context, we'll throw out the negative. So the geometric mean is just 10. So it said you could do the positive square root of their product. So it's saying if you just multiplied 4 and 25 and did the positive square root, that's going to give you the geometric mean. Same thing I got by showing you all the details in the cross multiplying. So I'm going to give you some numbers to find the geometric mean of. So you can set up the proportion and cross multiply. You can learn that it's just multiplying the two numbers and doing the positive square root. The proportion fits into our chapter better, but the other way is quicker. Okay, I'll just do that one for you. Okay, how about 5 and 30? What's the geometric mean of 5 and 30? And what's the geometric mean of 5 and 30? We don't want to round it. So we're going to have to go back to the remembering how do we do a simplifying square root. Simplifying the square root of 150? About 5 times the square root of 6. That's the geometric mean. If you would put that value in your proportions and reduce, which would be kind of hard to do, they would reduce to be the same thing. How about the geometric mean of 2 and 8? That one's a lot easier, isn't it? You can check that one a lot easier too. Geometric mean of 2 and 8 is 4. So as you think about the term mean, haven't you dealt with mean before? When it said find the mean of 2 and 8, what did you do? You add them up and divide by how many there are. Okay, that's really called an arithmetic mean, where you add and divide. And on geometric mean, you multiply and square root. So it's a different kind of average, a different kind of mean. Okay, how about one more? Find the geometric mean of 10 and 30. square root of 3, that's what I was thinking it came out to. Oops. Any question coming up with that? As I was clicking through things that I was skipping, I noticed that I skipped one like number 4, so let's at least take a look at it before I have you work on your assignment. An apartment building's 90 feet tall and 55 feet wide. If the scale model of this building is 11 inches wide, how tall is the scale model of the building? You can set up proportions, okay? And there's more than one way you could set it up. So if we compare height to height and width to width, that would be one way we could do it. How tall is the apartment building? 90 feet. How tall is the model? X, we don't know that one. How wide is the building? 55 feet, the actual building. And then how wide is the model? 11 inches. Now, you do not have to convert the feet into inches unless you really want to. As long as you have the same thing being compared, feet, what's X going to be in? Inches. Feet compared to inches, feet compared to inches. In that case, you can really ignore the units and just cross multiply. 90 times 1, or times 11, and then you're going to divide by 55. So I just wanted to make sure that you have thought of how you would set that up, because you do have something like that on a problem on your homework. So again, setting up the proportions in order to solve. Okay, let's get a few minutes squeezed in as far as some working on homework. And I did put, some of you are looking on eBackpack, I did pull your chapter 7, 8. I wrote out the assignments for you there. Those are ratios and proportions. Remember, the geometric mean part came from chapter 8. We're going to be kind of bouncing back and forth, combining those two lessons, or 2 chapters. So as I said, I did put the folder of chapter 7 and 8 on eBackpack, and there should be a document there that has the assignments for the chapter. Especially if you know you have an activity coming up, that might help you to work ahead and find out what you missed, rather than having to wait to come to class. There's what we'll have for Monday. And if some of you want to get some help thinking that you're going to retake that test, today's an access